Oh, so you think radar works on a spinning ball? Well, Globies, you thought wrong. Radars don't work, navigation doesn't work, compasses don't work on a spinning ball. You've been lied to, and that's why you're a slave. Peace and
First thing, where's your proof? You can't make a claim like that without any proof. Okay, let's just get into it. Radar works like this. You have your emitter that gives out your radio wave. That radio wave bounces back from an object, and then a receiver receives that wave. Now, then it uses a calculation to get your distance. This calculation is d equals c times the speed of light, because any radio wave moves the speed, or any radio wave or any electromagnetic wave moves at the speed of light. Multiply with the time it took for that wave to travel back. Then you get your distance. Now, yes, this can work on a flat earth, okay? Because it's on a flat surface, but then you can point it directly. But you will always see a radar at an elevated point. Doesn't matter what. And it is mostly for aviation to detect incoming flights, but it can also be used on the ocean. A higher you put your antenna or your radar, a greater distance you do have where you can pick up objects. Okay. Then you mentioned GPS. How GPS works is with a satellite that gives out a signal that gives you the location of that satellite and the exact time which that signal is sent. Now, this time is calculated with an atomic clock, and they calculate a time dilation in as well. Now, your phone receives this signal, and then it calculates with the time that it was received and the time it was sent. It calculates the distance from the satellite. That is the same equation with radar, where it is d for distance equals c, the time of light, or the speed of light, multiply with delta t, the time it took for that signal to reach your phone. Now, it's not just one satellite signal it receives. It receives about 3 to 4, depending on the location and which satellite is in orbit around you at that time. It gets an estimation of the distance of each satellite. It has each satellite's data of where they are in space, and through all of that data, you calculate where you are. Approximation, it can be within 15 meters. And still, the craziest thing about this claim is that it wouldn't work on a spinning globe. The reason why satellites can orbit is because it's around the object. Now, a satellite doesn't just float there in space. It is constantly falling towards Earth. With the speed it's moving, it keeps missing it. Now, as it orbits Earth, it starts getting closer and closer. But scientists and engineers had a way around this by using thrusters that boost the satellite's speed again, so it speeds up because it does lose momentum, it does lose speed, and it keeps its orbit. And then the craziest claim that you make is that compasses would not work on a globe. The whole reason why there is a magnetic field around Earth is because of the metal core, that hot compressed metal core. It is that metal core that creates your magnetic field around Earth. That magnetic field that is picked up by a compass. I don't understand how you can think that the magnetic field would work on a flat Earth. I never saw a magnetic field that has in the middle a magnet that has in the middle a north pole and on the side a south pole. It always arrange it on the one side is north, one side is south, even if it is round. But it's quite something interesting, just if you really think about it, it could mess you up a little bit. Is that the arrow you name the northern pole, which shows to the North Pole, actually shows to the South Pole, because north attracts south. And then the arrow on the compass that shows to the South Pole actually shows to the North Pole, if you think about it. But yeah,